Welcome back. This is an Aleks training video on recognizing exceptions to the octet rule. So I have told you that the octet rule is key in chemistry. All elements want a electron configuration that is the most stable, and the most stable is an octet that is filled. What I mean by octet is that the valence electrons have an electron configuration equal to a noble gas configuration. So that is the eighth column. So most of the time, it's going to observe the octet. There are some exceptions to this. Sometimes there's not 8 electrons to play with. Other times the molecule is so big that there is enough room for more than 8. You also have some stuff going on with some differences in electronegativity. So let's look at a few common exceptions. Okay, the first exception is anything in period 3 or higher. Okay, so in period 3 or more, you have enough room for more than 8 electrons. Okay, so sometimes more than 8 can fit, right? So if you have sulfur in the free state is S8. If you have phosphorus or any of these big elements like sulfur, phosphorus, anything in group 3 or above, you can have exceptions. Now, most of the time they're going to obey the octet rule, but if you can see a situation where there's less than 8, you just check yourself and say, okay, is it bigger than group 8? Is it bigger than period 3, or it's in period 3 or bigger? It's possible that you could have more than 8 in the outer shell. So that's the first one. All right, so the first one is more than 8 as long as it's in period 3 or above. The second one is not enough electrons for octet. So if you have only 5 electrons in the whole molecule, or you only have 4 electrons in the whole molecule, the chances are you are not going to have enough for an octet. So if you have a molecule of something small, a lot of times it's going to break the octet rule simply because there's no 8. All right. So if you have anything smaller than 8 electrons, when you count all the valence electrons and there's not 8, chances are it's going to break. Okay. The third is an odd number of electrons. An odd number of electrons sometimes crowds an electron in. So, like, let's say there's 9 electrons. Well, and there's 8 around. Sometimes it will force an electron to be fitting somewhere in. Okay, and the last is huge differences in electronegativity. So if you have something with a very large electronegativity and a very small electronegativity, so let's say you have something from group 7 which has very, very minus number, like a huge 300 and something minus number, but then you have something that it's joining to that has a huge positive electronegativity. That difference sometimes will mean that in order to finagle the differences, you don't have to have 8. Okay, so these are the 4. So we're going to look back at your question and see, can we come up with reasonable proposals to this. Okay, so your first one is hydrogen and beryllium combined. Okay, so you've got a BeH2. There is a molecule BeH2. Someone has proposed that this is the Lewis structure. And your question is it a reasonable proposal? Okay, knowing that there actually is a molecule where there's two hydrogens attached to a beryllium. Okay, if that be true, count all the valence electrons. Well, hydrogen has 2, its octet is met. Other hydrogen has 2, its octet is met, so that's not a problem. Beryllium does not have an octet, but none of these will. These are exceptions. All right, well, you're just asking yourself, is it reasonable? Okay, so how many does beryllium have? Beryllium only has 1. Or, I'm sorry, 2. Beryllium is in the second column, so it has 2. Well, altogether, you're going to have 1, 2, 3, 4. You only have 4 total, so you can't have 8. If you only have 4 electrons to play with, you cannot make beryllium have 8 because there isn't 8 to give it. So this is going to break the octet rule, and that's fine. And does it work? Yeah, H is stable, the other H is stable, all 4 electrons are used. So this is, ooh, what happened? That was crazy, man. It is a reasonable structure. Okay. What else we got? Second one is carbon dioxide. Okay, carbon dioxide. So is it the octet rule and the valence electrons? So how many valence electrons we have? We have 4 plus 6 plus 6. So 12, 13, 14, 15, 16. 16 total, that's 8 pairs. Okay, so I have 8 pairs of electrons. Here's 2, that's 1 pair. Here's 2, that's another pair. So I need how many more? 6. 1, 2, 3, 4. I don't have the right number of valence electrons, so this cannot be, and it has the wrong number of valence electrons. How many is the correct number? Okay, well, 12, 13, 14, 15, 16. The correct number is 16. There should be 16 valence electrons. Okay. And the last one here is phosphate. Now phosphate, oh goodness, look at the phosphorus. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 around that. Not 8, I've got 12. Well, it scares me to not do the octet, but I know that some things in group 3 and above can fit more. Is phosphorus in group 3? Or, yeah, not group 3, period 3. It is. So it's big enough to hold more than 8. So since I need a configuration that's got 1 phosphorus and 4 oxygens, we know it's actually a molecule, PO4 phosphate. It's a polyatomic ion. And a lot of times you're going to play with this with ions. Ions have to be exceptions because there's not the same number of electrons that would normally fit in a molecule. It's weird a little bit. So there's going to be breaking some rules. Well, this is obviously breaking rules, but it's big enough. It can handle it. It's big enough to handle it, so I will say yes, it's reasonable. Okay, so this is hard. I would say this is hard. You're going to have to think about this. You'll probably get a lot of these wrong and just do them again and again. But you're looking at those 4. Okay, those 4 again. Is it period 3 or more? Then they can fit 8. Okay, or are there not enough electrons for an octet? Then you're going to have a broken rule if you don't have 8 to play with. Sometimes an odd number of electrons, you're going to have to break a rule. And then if you have huge differences in electronegativity, so say aluminum or boron or beryllium added with something from group 7, sometimes you're going to break the rules there too. Okay, hope this helps.